Hello class, in this video we're going to take a look at how to calculate the area of a regular polygon. So in the previous video we learned some of the vocabulary of the parts of a regular polygon, like what we would call the sides, the apothem, the central angle, the center, the radius, and today we're going to start using those parts to find the area within a regular polygon. So we're actually going to be pulling some old information that we've learned a long time ago about areas of triangles and extend that and apply it in a new way. All right, so let's see if I can pull this up on the screen. All right, so this is going to continue us in section 11.3, and it's all about finding the area of a regular polygon. So you should know from way back that the area of a triangle can be calculated by taking 1/2 of the base times the height. We're going to be using this skill to find the area of a regular polygon by really breaking it down into triangles, so we can just use this formula that we know from a long time ago. So if you take a look at this regular polygon, this regular pentagon, we can find the area of this whole pentagon by finding the areas of triangles that are found in the interior. If we took the center and then drew in the different radii that we would have, we'd have 5 different radii from the center. And what that's going to do is that's going to take this pentagon and divide it into 5 different congruent triangles. If we can find the area of one of these triangles, then we could just multiply that by 5, and that'll give us the area of the whole pentagon. So that's the plan today, is to take a look at finding the area of one of these triangles and then multiplying by how many there are. The number of triangles will match the number of sides. So in this pentagon, we have 5 congruent triangles. In a hexagon, there would be 6. In an octagon, there would be 8. In a square, there would be 4. So how we're going to do that is, one thing we need to know is the, how do I move, get that out of here? Okay, that can't go away apparently. So we'll need to know the side of the pentagon, because that's really what's going to give us our base. So for example, if in this pentagon the side is 12, then the base of that triangle we're looking at would be 12. The height of that triangle would be the same as the apothem of the pentagon. So if we took 1/2 of the apothem times the side length, we would essentially be doing 1/2 the base times the height. And that would give us the area of this one triangle. So the area of this one triangle would be 1/2 the base is 12 times the height is 8.26. And so the area of that one triangle is 49.6. Well, there are 5 triangles, so if we take that area of 1 times the 5 triangles we have, that'll give us the overall area of the pentagon, 248. So that's what this is all about, is finding the area of one interior triangle and then multiplying by how many interior triangles we have. The area of any regular polygon, you can think of it in this way. The area is the area of one interior triangle times the number of interior triangles. And you could always think of it that way if you want to. Well, I'm going to show you this sort of shortcut formula that takes this and puts it into terms of the apothem and the side length and all that. So here's the formula I want you to know. Take notes, write this one down, make sure you know it. The area of a regular polygon is 1/2 A times S times N, where A is the apothem, that's essentially the height of the interior triangle. S is the side length, that's essentially the base of the triangle. And then N is the number of sides, and that's how many interior triangles there are. So remember that formula. Area of a regular pentagon, or any regular polygon, could be a pentagon, a hexagon, anything else, is 1/2 apothem times side length times number of sides. So let's take a look at an example. Before we do, let's break it down. So the area of the interior triangle is this part here, the 1/2 apothem times side length. And then the N is the number of interior triangles. So we're just taking that idea and sort of converting it or condensing it down into one formula that works for any regular polygon. So here's an example. Here we've got a regular, let's see, 1, 2, 3, 4, 5, 6. We got a regular hexagon. And I've got some information about some lengths in that hexagon. So to find the area of this hexagon, well, we're going to find the area of this one triangle and then multiply by 6 because there are 6 triangles. So the area of this triangle would be 1/2 the apothem, 13.86, times the side length, 16, times 6 because there are 6 triangles. So the area is 1/2 the apothem, 13.86, times the side length, 16, times the number of sides, 6, and that product altogether gives us our area of 665.3 square units. So 1/2 of the apothem times the side length times the number of sides. Let's take a look at another example. Here we have 1, 2, 3, 4, 5, 6, 7 sides. So you've got a heptagon or septagon. And so if you want to find the area of that regular polygon, it's a good idea to pause the video and see if you can find that on your own. All right, well, let's see what we have. So even though this 10 is the side length that's not connected to this triangle, since this is a regular polygon, all the sides are 10. So this side here connected to the triangle is 10. So we have 1/2 of this apothem, 10.38, times that side length, 10, times there would be 7 triangles altogether, is going to give us our area. So 1/2 of 10.38 times 10 times 7. That's 1/2 of the apothem times the side length times the number of sides gives us our area, 363.3 square units. Take a look at one last example. Now this one has an additional piece of information that we won't need to use in our formula at all. The only things we need to use in our formula for area of a regular polygon are the apothem, the side length, and the number of sides. Let's see, which one here is the apothem? Well, that would be 30.78. The apothem is the segment that goes from the center to the side at a right angle, 30.78. What is our side length? Well, that would be 20. All the sides are 20. And then the number of sides, we can just count those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So n is 10. This here, 32.36, is the radius, and we don't need to use the radius when we calculate the area. So to calculate the area, we would do 1/2 apothem times side length times the number of sides. And when you substitute those in, you'll have 1/2 times 30.78 times 20 times 10. And altogether, that is our area, 3,078 square units. So from this video, you should be able to calculate the area of any regular polygon using this formula. Area equals 1/2 apothem times side length times the number of sides. In the next video, we are going to look at examples that are a little bit more difficult where some things aren't given, like the apothem or the side length. We might have to use things like special right triangles, 30, 60, 90, 45, 45, 90, or Pythagorean theorem to find those missing parts. But from this video, just the basics of being able to use area equals 1/2 times apothem times side length times number of sides to find the area of a regular polygon.